Hello class, in this video we're going to be making predictions using the line of best fit equation. Now I'm hoping that you still recall and know how to determine the equation for the line of best fit using your CAS calculators from the previous lesson. I'm going to quickly review over what the line of best fit is. We said that the line of best fit is essentially a line found on a scatter plot that helps us better represent the data. So in doing so, what this allows us to see is how are the two variables correlated between those two sets of data over there. This is pretty much the important point for this particular topic. We use the line of best fit because it allows us to make estimations for a particular variable from the equation over here, and there are two techniques or two processes that we could use. One of them is referred to as interpolation and the other one is referred to as extrapolation, and you need to know the two differences between them. So before I even unpack what those two terms mean, I want to quickly explain to you what I mean as to we predict what the value is using the actual line of best fit. So for instance over here, I could say I want to know what is the total number of sales that I've actually made when the temperature is 21 degrees. So using the line of best fit, once you've actually drawn your line of best fit, I can kind of roughly estimate what my value is because I can just eyeball it. In this case over here, 21 degrees lies over here along the x-axis. So that at this point over here is where it intersects your line in this case. And I wanted to find out what was the total number of sales that I've made. So if I do that over here, I can kind of eyeball and say, well, that's going to be roughly $470 that I've actually made. So this is what I mean by making estimations using the line of best fit. However, we're going to be looking at in more detail how could we actually use the equation to make more accurate estimations. Now we're going to be looking at extrapolation versus interpolation. What I'm going to be doing now is I'm going to be taking a literacy point of view so that you have a better understanding of what these two terms mean. So you've got the words interpolation and the word extrapolation. What we're going to be looking through is the meaning behind the two prefixes. So you got the prefix over here, inter and extra. So for instance, if you've got the word inter-school sports, we know that inter-school sports means it's a competition between schools. So inter means between, and the word extra means beyond or outside. So extraordinary in this case over here would mean it's beyond normal. Ordinary means normal. We can kind of use these two terms over here to make a prediction of what the definitions of interpolation or extrapolation is. So since inter means between, this means that you're estimating between something, whereas extrapolation means you're estimating a number that lies outside of something. So now let's look at the formal definitions of these words to see whether our predictions of these definitions are accurate or not. So over here, I've got the definitions between the two words. I've got interpolation, and look over here, it says interpolation is the estimation of value that lies between two known values. In this case, that's going to be pretty much the largest value and the lowest value. So anything that lies within the data set in this case is interpolation. So for instance, as you can see over here, if you were trying to find out what is the total number of sales you made when it's 21 degrees, this is an example of interpolation because the value that you're trying to find is contained or within the lowest and the largest data values. On the other hand, extrapolation involves estimating data points that lie outside the range of the data set. So for instance, over here, the largest value in this case was roughly 25 and a half or so. If you were trying to find out what is the total number of sales when it's 29 degrees, this is an example of extrapolation. So you do need to understand the fundamental differences between these two estimation techniques. All right, so how do we estimate the values graphically? I've kind of shown you this previously in the other example, but I'm going to be using another example over here just so you understand what I mean by this. So using this example over here, the question reads, predict the amount of money earned from 8 hours of babysitting. Well, I can see that babysitting is my x-axis over here. So I want to find out the amount of money. So I want to try to find out what the y value is. The x value in this case was 8. So if I was to draw a line like this where it intersects with the equation, or I mean with the line of best fit, it's going to hit it over here. I now want to find out what is the y value that corresponds to this. So I'm going to draw a horizontal line such that it hits the y-axis. If that's the case over here, I can kind of assume in this case that the amount I've earned is in this case is going to be equal to $13 because this over here exactly crosses over at this particular point, and I can say with high certainty because it crosses over this point it is equal to 13. However, some of the examples that you're going to be looking at are more ambiguous than that, and it's probably going to be a lot more harder to make a formal judgment. This is what I mean by this. So looking at another example over here, let's say predict the cost to hold a party if 20 people attended. So people is along the x-axis. So I'm trying to find out what is the cost when there's 20 people. 20 is over here at this particular point. So if I was to draw a vertical line going as such, I want to find out what is the y value at this particular point. Now, if you can actually zoom in or you have really good vision, you can kind of see that this isn't really halfway in between this box over here. And because it's not exactly half, it's kind of hard for us to make a accurate judgment as to what that cost is. Is that equal to 550? Is that equal to 555, 560? We don't know because we don't have a proper interval for us to see it exactly. So what I'm saying is, we can kind of approximate, okay, with very low certainty that the cost is going to be roughly around 550. I can't say it with high certainty as I did in the other question because that one, it crossed exactly where the 13 mark is going to be. So in this case of here, you can kind of see that when we generally eyeball using interpolation or extrapolation, it's not going to be very accurate at all. Alright, let's look at a better example so you have a better understanding of the differences between interpolation versus extrapolation. So the question reads, consider the figure shown below. The line of best fit on the scatter plot is used to predict the values of y when x is equal to 15, x is equal to 40, and x equals to 60. So first of all, when it says, because we're trying to find out the y value of these 3 points over here, x equals to 15, that is over here. So what I'm going to be doing is I'm just going to be drawing a line as such. The question wants you to read, what is the estimated y value when x is equal to 15? Notice that this particular point lies outside of the data range. So your smallest x value is over here, your largest x value is over here. The x equals 15 lies outside of that. So in this case of here, because it lies outside, this is an example of extrapolation. In contrast, x equals to 40, that lies over here. So you're trying to find out what the y value is at this particular point. Because this lies within or is contained within the data set, this is an example of interpolation. And lastly, when x equals to 60, that's when it's over here. So this is an example of extrapolation. All right, now let's actually answer the question. Interpolation would be used to predict the value of y when the value of x is equal to which one? So remember, interpolation, inter means between, so you're trying to find the value of a variable when it's contained within the data set. In this example over here, the only correct answer in this case is this one over here when you're trying to find out the y value when x is equal to 40. So therefore, D is going to be the correct answer. Now, before we proceed on to the next topic, I do want to quickly emphasize that the examples that we just looked at were very inaccurate ways to actually estimate the value for a particular data set or a particular variable. The reason why it was very inaccurate is because we were essentially just eyeballing it. And depending on the actual scale of our scatter plot, this is going to make it a lot more hard and a lot more subjective between two or more people. So what we're going to be doing is we're going to be looking at a way or a technique for us to make these estimations a lot more accurate, and then we're going to be looking at the limitations of extrapolation and interpolation in terms of their accuracy itself. So first of all, example 1, the question reads, using interpolation and the following data set, predict the height of an 8-year-old girl. Now these three steps over here, they are not the actual questions. These are steps that will help you get to the answer. So the first step, what we need to do is we need to generate the equation for the line of best fit. Now, obviously, we don't even have a scatter plot. It only gives us this particular data set over here. So what we're going to be doing first is we need to actually draw the scatter plot using the Excel spreadsheet on the CAS calculator to therefore generate the line of best fit. Now, remember, step 1, before we even put the values into a CAS calculator, we need to identify what is the explanatory variable and what is the response variable. So remember, the explanatory variable is the variable that influences the values of the response variable. So in this case here, does age influence or determine how tall you are going to be, so your height, or does height determine and slash influence your age? In this case up here, you would agree with me that age influences height. As a result, age is therefore going to be the explanatory variable, and height is therefore the response variable. What you do next is, after you've identified this, I need you to put these values inside your CAS calculator. Once you do that, then you can go to the calculator function, click on statistics, stat calculations, linear regression, and find out what is the equation for the line of best fit. If you do this successfully, this is the page or window that you should have, and these are the values associated with that. So as a result of that, your equation for the line of best fit should look like y is therefore equal to 55.6286 plus 9.22857x. Now, what you need to do as for step number 2, you need to replace the letters or the variables x and y with the variables that are provided within the question. In this case here, the variables were age and height, and we said that explanatory variable is the x in this case, because explanatory variable is always drawn or represented along the x-axis. Response variable is always represented along the y-axis. So wherever I see x, I'm going to replace that with age, and wherever I see y, I'm going to replace that with height. So therefore, your equation should look something similar to this. Now, you don't need to include brackets as I've done over here, but because this x is multiplying by 9.22, I kind of wanted to just show that, because again, when we're doing calculations, you got to follow BODMAS. So I'm just going to be putting brackets, just indicate that you need to multiply first before you can actually add. Step number 3 says we need to substitute 8 for age and to solve the problem, because what the question is asking is, you need to figure out what is the height of the 8-year-old girl, or when the girl is 8. So because we're trying to find what height is, substitute 8 in this equation over here. So if you do that, your equation will look height is equal to 55.6286 plus bracket 9.22857 multiplied by 8. Put this into your calculator and you should get an answer of 129.45716 centimeters. And if you were to round this to 2 decimal places, because you've got a ridiculous number of decimals, then your answer should therefore be 129.46 centimeters. Remember, we generally put it to 2 decimal places if the question hasn't actually given it or hasn't actually stated it otherwise. Now, for this particular example over here, we're again using the exact same data set from the previous example. However, this is a bit different because now we're going to be using extrapolation instead to predict the height. So now we're going to be predicting the height of the girl when she is 15 years of age. And then the question also wants us to discuss the reliability of this prediction. So can we use the equation to safely conclude that she will be this tall or roughly this tall? So the way that we do this again is we're going to be substituting 15 into our equation over here. So if you do that, this is what your equation should look like. And if you put this into your calculator, your answer that you should get is 194 centimeters and 0.05715. But we want to round this to 2 decimal places. So therefore, this is the answer that you should obtain. So we've now answered the first part of the question. Now the question wants us to also analyze the result to describe the reliability. Now, to answer that question over here, we need to kind of refer back to the actual scatter plot. So this is the scatter plot for this particular set of data over here. So as you can see over here, this is the range of data set. And as you can see, this does follow a linear trend. Now, the reason or one of the limitations with extrapolation is that if you're trying to figure out what is the age when she's 15, so let's say that's over here, you're kind of assuming that she is going to be this tall when she is 15 years of age. One of the limitations with extrapolation is that any values that lie outside of the data set may not follow the trend that we initially thought it would. So for instance, if I was to figure out like what is she is in 20 years of age, she may not be growing at the exact same rate as she was when she was in her teenage age. So instead of growing at that same rate, that rate will decrease. So she will probably be a bit more low than that. She might be over here. Maybe she could even be over here. Maybe she could be up here or up over here. We don't even know. So that's one of the limitations of extrapolation. So the way that I'd answer the second part of the question, I'd say extrapolation is not very accurate since we are predicting outside of the data set. It assumes that there's the same trend outside of the data set and the girl will grow at the same rate at the age of 15. So that is how I would answer this particular example over here. But the way that what you should include in your cheat sheet, because this is a question that is often asked in your test papers, is that extrapolating is not a very accurate way to estimate because it assumes there is a definite linear relationship for all values. So in this diagram over here, if this is all your data set over here and what you want is to find out what is the x value at this particular point over here, you would think using the line of best fit, the equation of the line of best fit, this is the predicted y value. However, in reality, it doesn't actually follow this linear trend when it's outside of this value at all. It might follow this non-linear trend as you can see over here. So, hence it assumes that the estimated value follows the same trend, which may not be true at all. Please make sure that you do copy this particular slide, as this slide is very, very important. Once we do that, we can now check with your understanding. So please pause the video right now to see whether your answer for this multiple choice matches my answer. So the question reads, the scatter plot below is used to predict the value of y when x is 300. I'm sorry for that, the question is kind of blurry. This prediction is what? So 300 when x is equal to 300, that's over here. Now, because this value is within the data set, this is an example of interpolation. Hopefully you can agree with me on that. And because this is found within the data set over here, interpolation will always be a lot more accurate as opposed to extrapolation, because we can see when the data set is within, when the value that we want to find is within the data set, we know this follows a linear trend. However, when it's outside of the data set, it may not even follow a linear trend at all. So in this case over here, this prediction is reliable because it is obtained using interpolation. You know, A seems reasonable for now, so let's leave that as a possible answer and let's eliminate all the other options. Part B says it's not reliable, so we can eliminate option B automatically. It's also not reliable for part C, so we can eliminate that. D says it is reliable because because the scatter plot contains a large number of points. Now that's not true at all, because the number of points have no correlation to the accuracy of the estimation. So D is also incorrect. E is therefore incorrect, so therefore the best answer in this case is actually option A. Again, I'm going to go through some more examples over here. So please pause the video right now so you can answer this question. Although the suggested time frame was 10 minutes, it's probably going to take you a bit longer than that since you're still new to this topic. The question reads, the following table shows the gestation time. So I think gestation just means how long the baby is in the mum's womb, and the birth mass of 10 babies. Use the CAS calculator to answer the following questions. So the first question wants you to describe the correlation in terms of direction, strength, and form. Now, because we're trying to explain or describe the correlation, what we need to do first is we need to pretty much draw or construct a scatter plot to see whether to see the form of it. So to see whether it's linear or non-linear. We need to see the directions to see whether it's a positive graph or a negative graph. And we also need to draw the scatter plot because this will indicate what the strength is going to be. So I'm going to be playing this video over here right now. So again, what your first step should be is that you should be putting all the values into your calculator. So I didn't write gestation, I just wrote time in my first column, and I put mass in my second column. If you do all of that, then, oh, I kind of skipped that accidentally. If you do all of that and put all your values in, click on this icon over here. We know that gestation time in this case is your explanatory variable because your time determines how heavy you're going to be. And if this is the case, this is the scatter plot that you should have. As we can see, this is a positive, has a positive correlation. We could also say this is also linear as well. And to accurately determine what the strength is going to be, remember I said we need to calculate what Pearson's correlation coefficient. If you do this, and I haven't actually shown this at all, if you do this, your Pearson's correlation coefficient should equal to 0.99, which clearly indicates that this is a highly strong correlation. So therefore, if you're using the template, your answer should be the scatter plot suggests a strong positive linear correlation between gestation time and birth mass. Now for part B, to answer part B wants us to determine the equation for the line of best fit. Write it in terms of T and M. And T represents gestation time, M represents birth mass. So what we need to do is, since we've already put our values into the Excel sheet, go into the calculator function to find out what your equation is going to be. So you should see this variable over here. We said that time in this case was the explanatory variable, so this is going to where X is. Your mass is going to be your response variable, so your Y axis. If you put this down, these are the values that you should see on your window. And therefore, please write down the equation for the line of best fit. So I'm writing it first in terms of Y and X, but the question wants us to write it in terms of T and M. T represents your gestation, which is your X. Birth mass represents your Y. So wherever you see Y, replace that with birth mass or replace it with M. So I'm just going to be using the letters that the question stated us to do. So therefore, it's going to be M is equal to negative 6.40782 plus 0.246727 T. Part C says, although full-term gestation is considered to be 40 weeks, some pregnancies last longer. So in this case over here, I'm already getting the idea is we're going to be extrapolating this case. So it wants us to find out the Y values or the birth mass when it's after 41 weeks and after 42 weeks. So what we're going to do is we're going to substitute 41 and 42 to where T is. If we do that, it will be M is equal to negative 6.40782 plus 0.246727 times by 41. So I've substituted 41 into the equation over here. Put this into your calculator. You should get this as an answer. Do the same thing to find out what is the baby's mass after 42 weeks. And therefore, you should get an answer of 3.954714 kilograms. For part D, many babies are born prematurely. Using the equation obtained in part B, predict the birth mass. So this is an example of extrapolation again, because 30 weeks lies outside of the data set over here. So again, all we're doing is substituting 30 to wherever I see T. And if you do this, you should get an answer of 0.99399 kilograms. Part E, if the birth mass of the baby was 2.39 kilograms, what was his or her gestation time? So you're trying to find time in this case over here. So there's actually two methods that you could actually do in order to arrive to the answer. So the first method is using proper algebra. We're trying to find out what is T when birth mass is equal to this. So I'm substituting 2.390 wherever I see the capital M. This should give you something similar to this. And what we're going to do is we're going to solve for T. We want to get T by itself. So since this over here is also on the right hand side, we're going to eliminate the negative 6.40782 by adding 6.40782 on both sides of the equation. If you do that, this cancels this out. So therefore, find out what the sum of these two values is. That's going to equal to 8.79782. And since this number over here is being multiplied with T, we're going to divide both sides of the equation by 0.24. So this is what you should obtain. Put this into your calculator. So divide these two values together. You're going to get an answer of 35.65812. And therefore, because the question wants us to round it to the nearest weeks or to the nearest whole number, your answer is going to be 36 weeks. Now, did I confuse you? I probably did, because this over here, this is a lot of algebra, and this is not really required for you as a further maths student. This is more maths A kind of stuff where we kind of do more by hand calculations. On the right hand side of the screen, I'm going to be showing you how we could actually use the CAS calculator to solve for T. So please pay attention. So what I'm going to be doing is I'm going to be writing this exact equation over here, but I need to write the word solve first. So type in solve, bracket, and then type in your equation. Now, after you finish writing down the equation into your calculator, write down comma. So the comma is found over here, comma, and write down what letter you're trying to find. In this case, I'm trying to solve for T. So I'm going to go write comma T and hit the enter button. If you do this, it will give you the exact same answer as I did by calculating by hand. And again, we need to round it to the nearest week, so the nearest whole number, which again is equal to 36 weeks. Okay, now is the time for you to apply your understanding by answering these textbook questions. So I'd like you to use the remaining class time as well as for homework to complete the following questions. I've got the answers towards the end of the slide, so please refer to my PowerPoint slide to answer the questions, and the last page should have all the answers. So answer questions 1, 2, 3, questions 4, 5, 6, 7, and these are the answers over here. Afterwards, I do want you to make sure you are grabbing a red pen out and cross-checking whether your answers are correct. And once you do this, please upload all of your work onto Compass so I can see your work progress. This is the end of the video. Thank you guys for watching. See you in the next video. Bye.